Continuing to work with algebraic fractions, we're going to look at multiplying and dividing, which is really not much different, not much of a leap from doing the simplifying fractions as when we're multiplying. So we're just, we already know how to multiply fractions generally, right? You just multiply the two numerators, put them on top. You multiply the two denominators, put them on the bottom. When you divide fractions, you just you turn it into a multiplication problem. Dividing by a fraction is the same as multiplying by its reciprocal. So that first fraction stays the same, a over b, and then we multiply by the reciprocal of the denominator. We always begin these by factoring. Factor everything first. If you see a problem like this, the one that we're looking at here, in example 110, and your first step is to try to expand all the products, you're making your life a million times harder than it needs to be. You're actually undoing the work you need to do. So we're going to start out by factoring everything that we'll factor. In the first fraction, we can unfoil this. This is x minus 2, x minus 2. In the bottom, we can unfoil that. Let's see, we need an x and an x. Let's see, a negative 6 in the end and a plus 1, so we need a plus 3 minus 2. In the second fraction, in the top we can factor out a common factor of x, and then we have x plus 3. And then in the bottom, again, we can factor out an x, and we've got x minus 1. So now that everything's factored, we just whip into a frenzy of cancel anything that will cancel. So we have an x minus 2 and an x minus 2. We've got an x plus 3 and an x plus 3, and we've got a common factor of x. And then we just write out what we're left with. On top we have x minus 2. On the bottom we've got x minus 1. And that's our final result. Let's do another one here. Again, we're going to start by factoring everything. Up top, we'll start in the first fraction here. Up top we could take out a 2, and then we're left with x minus 2. In the bottom we could take out a 4, and we're left with x plus 3. In the second fraction, up top we can, let's see if this will unfoil. If it's going to unfoil, then the first two terms have to multiply out to a 2x squared, so we'll need a 2x and an x. We need a negative 15 at the end, and we need our middle term to be just a plus 1x. So I think what we want is a 3 here and a 5 here, because this will be a 6x and that'll be a 5x. And then we need the signs to work out, so we have a positive 1x. So I think we want plus 3 minus 5. That'll give us the plus 1x. In the bottom, 3x minus 1, that's already factored. It's a linear factor, so let's leave it like that. Now everything's factored. We're just going to whip into a frenzy of cancel whatever will cancel, which is not a whole lot in this case. The x plus 3's will go. 2 will cancel with the 4, right? 2 goes into 4 twice. And then we see what we're left with. Up top, we've got a factor of x minus 2 and a factor of 2x minus 5. In the bottom, we have a factor of 2 and 3x minus 1. Now, it really makes sense to just leave it like this. If you want, you can multiply things out, but it doesn't really get us anything. And it's useful to kind of see a fraction in its factored form. Okay, let's move on to some division. The first step in a division problem is to turn it into a multiplication problem. So the first fraction is the same, and then I'm just going to flip the second fraction over. Now we'll factor everything that'll factor in the first fraction. Nothing it's already factored all the way. In the second fraction, we could take out a 3 up top. And we have 2x plus 5y. And then in the bottom, we could take out a 2. And we have x plus y. And now we'll cancel what will cancel. So the 3's are gone. The x plus y's cancel. We are left with up top 2x plus 5y over 2. You can leave it like this, or if you like, you could split it up. Let's see. So if I kind of split it up over addition in the numerator, we have 2x over 2 plus 5y over 2, and then we'd probably reduce, so we'd call this x plus 5 halves y. So either of these is fine. Alright, let's do one more. We're going to do this division. Again, we're going to start out by turning this division problem into a multiplication problem. Flipping over the second fraction, so up top on the second fraction I'm going to have 2x squared plus x minus 6. And in the bottom, 2x squared minus x minus 15. I have not spent a lot of time saying this yet, but I hope we all understand that we cannot cancel over addition. So in other words, like the 2x squareds there do not cancel, because those are not factors, they're terms that are being added or subtracted. They're not factors that are being multiplied. That's why we always start these problems after they're written as a product. Always start them by factoring everything. So x squared minus 9, that's a difference of squares. X plus 3, x minus 3. On the bottom, 4x squared minus 9, that is also a difference of squares. 4x squared is the square of 2x. So this is 2x plus 3, 2x minus 3. And over in this fraction, we're going to do some unfoiling. The first terms have to multiply out to 2x squared, so 2x and x. We need a minus 6 at the end and a plus 1x in the middle. So I think a 2 over here and a 3 here ought to do it. No, wait, yes it will. A plus 2 and a minus 3. Going to do a quick check here. This is plus 4x minus 3x, so that works out there. On the bottom, going to unfoil this. Again, we're going to need a 2x and an x. We need a minus 15 and a minus 1x in the middle. So let's see. Minus 5 plus 3, maybe? So that's a plus 6x minus 5x. So that'll give me a plus x and a minus x. So I think the numbers are fine. I got to change these signs around. So there's a plus 5x inner, minus 6x outer. So that'll work. Now let's cancel what will cancel. 2x minus 3 cancels with the 2x minus 3. X minus 3 cancels with this x minus 3. I think that is everything that will cancel. What we're left with on top is x plus 3 times x plus 2 over 2x plus 3 times 2x plus 5. And I'm just going to leave it like that.